Good morning. The topic under discussion is array. The subtopics are introduction of the array, declaring arrays, passing arrays to the method, copying of arrays, multidimensional arrays, and searching and sorting methods. First of all, I would like to give the introduction about an array. Array is a data structure that represents a collection of same data types. As you can see in the figure represents multiple elements in a single list, which is referred as an array. Next topic is how to declare an array. To declare an array, we first need to specify the data types with the index and then the variable name. A variable name can be any variable whose name starts with characters and which should not contain any special character. Data types can be integer, float, or any primitive data type. There are two methods to declare an array, implicit as well as explicit. Here we are using the explicit declaration, in which we are using new operator. This is again the definition of an array. To specify the length of an array, we use array variable dot length. Array variable is any variable name of array with length. So as you can see in the example, my list is the name of the array. Dot length will return me the length of an array, which is 10 in this case. Next is how to initialize an array. To initialize an array, we use the loops, and also we can do it directly. As you can see in the slide, there are two methods, by using loop as well as by declaring an array initializing, which is done in a single step. By using loop, we just need to specify the variable name which is given to the my list. My list is the name of an array. And in the second case, you can see we are declaring and creating the array in a single step. This is again the shorthand notation to create an array and to declare an array. Another topic is dragged array. Each row in a two-dimensional array is itself an array, so the row can have different length. Such an array is referred as dragged array, as you can see in the example given below. Next topic is to add two matrices. What is a matrix? A matrix is again an example of two-dimensional array. So in this case, you can see we are having one matrix, that is one multidimensional array, and another matrix, that is another multidimensional array. Both have been added to create another matrix, which is again another multidimensional array, or you can say a two-dimensional array. Next, we are having one example in which we have to calculate the score. The objective is write a program that calculates the total score for the student in a class. Suppose the score is stored in three-dimensional array named score. The first index in score refers to a student, the second refers to a class, and the third refers to the part of exam. Next topic is searching an array. Searching is the process of looking for a specific element in an array. For example, discovering whether a certain score is included in a list of scores. Searching, like sorting, is a common task in computer programming. There are many algorithms and data structures devoted to searching. In this section, two commonly used approaches are discussed: linear search and binary search. What is a linear search? The linear search approach compares the key with each element in the array list. The method continues to do so until the key matches an element in the list, or the list is exhausted without a match being found. If a match is made, the linear search returns the index of the element in the array that match the key. If no match is found, the search returns -1. So this is the example in which the objective is to implement the test, the linear search method, by creating an array of 10 elements of integer type randomly and then displaying this array. So you have to click here to get the example of linear search, and you have to click here to run that example. Next is binary search. In the binary search, for binary search to work, the elements in the array must already be in ordered form. Without loss of generality, assume that the array is in ascending order. As you can see in this particular slide, we have taken a list which is already in ascending order. The binary search first compared the key with the element in the middle of the array. So here we can consider three cases. In the first case, if the key is less than the middle element, we only need to search the key in the first half of the array. In the second case, if the key is equal to the middle element, the search ends with a match. And in the last case, if the key is greater than the middle element, you only need to search the key in the second half of the array. So this is the end of my presentation. Thank you.